Okay, let's keep going with our word problems. I'm going to be doing questions 9, 10, and 11 on this video. So if you haven't tried all of those, press pause, press stop, try them, and come on back. Number 9. Sony has been selling a new gaming console. The daily production cost is given by the relation right here. C equals 0.4 g squared minus 1.6 g plus 428. C is the cost in dollars and G is the number of consoles that are being produced. How many consoles should be created, not creating, to minimize production cost? And then what is that cost associated with that number of consoles? We see the word minimize that says, hey, find the minimum value, which is part of the vertex. To find the vertex, you know, we need to complete the square. We've already got our equation in standard form. And from there, I'm going to go through my regular steps. So I'm going to factor out A. Okay, so then I'm going to find my M value, which is B divided by 2. That gives me negative 2. Squared is positive 4. We're going to add 4 and subtract 4. I'm going to move this negative M out by multiplying it by A. So 0.4 times negative 4 is negative 1.6. And then I factor my perfect square. Just checking my mail there, or my math. All right, so my vertex is at 2 and 426.4. All right, so what does this mean? Well, that's G and that's C. To minimize production cost, 2 consoles should be produced. That doesn't sound like much, but you know what? Let's just go with this. To minimize cost, 2 consoles should be produced each day. I feel like that should have been in hundreds or thousands, but that's not what the question says. For a total cost of $426.40. And that's it for number 9. Press pause if you need a moment there. I'm going to move on to number 10. Now in 10 and 11, I gave you the formulas, but I didn't show you how I got them. All right, so when we look at this, a 200-meter string is used to create the perimeter of a rectangular area. It's got 4 sides. I obviously did a terrible thing here. 2 lengths and 2 widths. So the perimeter is length plus width, which is 2 length plus 2 width. Well, I know the perimeter is 200. I'm going to isolate L, so I'm going to divide them all by 2, which gives me 100 equals L plus W. And I can rearrange to see that L is equal to 100 minus W. In my area formula of length times width, I'm now going to sub this in for L. And this right here is where I expect you to be able to start from. Okay? So now I'll use distributive property to get into standard form. Pardon me. So when I rearrange, that's negative W squared plus 100W. I want to know the maximum area. It's time to complete the square. Factor out A, which in this case is just negative 1. Find my M value by taking my B value of negative 100, dividing it by 2, that gives me negative 50. Squaring it gives me 2,500, so I add and then subtract 2,500. I multiply this by negative 1, my A value, to move it outside of the brackets, which leaves me with positive 2,500. Then I factor my my perfect square inside the brackets. Very sorry, I've done a lot of recording today. Plus 2,500. So my vertex is 50 and 2,500. Now what do each of these mean? 50 is my width, 2,500 is my area. So width is 50 meters. length, I see right here, equals 100 minus W. W is 50, so that also gives us 50 meters. So I can say the maximum area is 2,500 meters squared with dimensions of 50 meters by 50 meters. Done. Press pause to finish that up. I'm going to go on to number 11. This is another area question. And again, I'll show you how I set it up, but then I'll show you where you're expected to start from. You have a 500-foot roll of fencing and a large field that's against a school wall. You want to construct a rectangular playground area with 3 sides. The fourth side is going to be the wall of the school. What are the dimensions of the largest such yard, and what is the largest area? So this is my school wall. I labeled my 3 sides as length, length, and width. I know that these 3 sides add up to 500 feet. Well, I can isolate W to give me 500 minus 2L. Area is length times width, so I just sub this in for W, so length times 500 times 2L. And I've given you this formula. This is where I expect you to start. I'm going to use distributive property to expand, which would give me 500L minus 2L squared. In proper order, that's negative 2L squared plus 500L. And I'm going to complete the square. So I factor out my A value, which leaves me with L squared minus 250L inside the brackets. I'm going to find my M value by dividing B by 2. So 250 divided by 2 is 125. When I square it, that gives me 15625. So I'm going to add it and subtract it in the same step because I can't change the overall value of the equation. I'm going to kick this negative M value out by multiplying it by A. So times negative 2 gives me positive 31250. And then I'm going to factor my perfect square. So L plus B over 2, which gives me L minus 125 squared plus 31250. My vertex is 125 and 31250. 125 is my length in this case. 31250 is my area. So length is 125 meters. Width is 500 minus 2 times length. So 500 minus 2 times 125. So my width is 250 meters. Therefore, the maximum area is 31,250. Sorry, this is feet. Force of habit, I go to meters. But squared. The length is 125 feet. And the width is 250 feet. And that wraps up question 11. So go ahead and try the last two, 12 and 13, and pop back. I've got one more video for you.